Hello everyone and welcome to PA Academy. So in this video we are going to be looking at Kirchhoff's current law. Now in the previous video we looked at Kirchhoff voltage law, we've looked at what Kirchhoff voltage law is all about, and I also showed you an example on Kirchhoff current law. So if you missed that video, there is a link to that video in the description of this particular video. So now let's look at Kirchhoff current law. Now Kirchhoff current law, it states that, so let me write it out. Now it states that the algebraic sum of electric currents entering and leaving a node or is equal to 0. Now, what is this saying? Now, they're saying that what the algebraic sum of electric currents entering or leaving a node or junction is equal to 0. Now, if you are talking about a node and a junction, I've also done a video that talks about the difference between a node, a junction, branches, element, and every other thing. All the links to those videos, I'll leave them in the description of this particular video. Now, for us to explain this, we have to first of all draw a circuit. So let me just draw a circuit here. So if you have something like this, and then here we have a voltage source, and then we have another voltage source here, and then right there we have a resistor. So let's call this resistor R1, let's call this R2, and let's call this R3. So the voltage source, this is Vs, let's call it voltage source 1 and voltage source 2. So let me add the polarity here, plus minus, the longer side plus, and this is minus. Now in this circuit that we are having here, now let me also indicate the nodes. Now this is a node, this right here is a node. I've also explained in that video I did. Now I said a node is a point of connection between two or more elements, while junction is a point of connection between 3 or more. So this is a node, we can also call it a junction because it's connecting 3 elements. So I said that what it is, Kirchhoff current law states that the algebraic sum of electric currents entering and leaving a node or junction is equal to B. Now let's call this point, this node A, let's call this B, and then let's call this C. Now for this, now we are having two mesh. Now a mesh is a closed part in a circuit. So this is a mesh, and this is also a mesh. But now since we are dealing with Kirchhoff current law, now we are going to be using this node as our reference point, so for us to explain Kirchhoff current law. It says what the current entering or leaving a node or junction. So let's use this as an example. Now let's say at this particular node we have currents entering this node like this. Let's call this current I1. We also have another current entering this from this direction. Let's call this I2, and then we have another current leaving this node B. So let's call it I3. So before we indicate this, there's also something I want us to note is this. Now when you are dealing with Kirchhoff current law and you have identified your node, so it's also important for you to know that all incoming currents are what? They are always positive. You take them to be positive, while all outgoing currents we take them to be negative. So if you can note this too, it will help you when you are dealing with any analysis or any circuit applying Kirchhoff current law. So now with the knowledge of this and with what we have there, now let's analyze this node B. Now we'll write that at node B, now let's identify the incoming currents. Now the incoming currents, so looking at it, what are the incoming currents? You can see I1 is the incoming current, is moving towards B, and I2 is also an incoming current moving towards B. So our incoming current is I1 and I2. What about our outgoing current? So our outgoing current, that's one that is leaving B, is I3. So these are the current incoming and the outgoing current. Now let me also add the polarities. Remember I said for all the incoming currents they are always positive, so let me indicate it here that this is plus I1 and this is plus I2. For the outgoing current, which is I3, let me indicate it as what? I3. Now with the knowledge of this, now let's go back to what Kirchhoff current law is saying. It says that what? The algebraic sum of electric current entering and leaving a node or junction is equal to 0. So with what we have here now, if you are to apply Kirchhoff current law, so by the time we had these three currents together, it's going to give us 0. That means we are going to be having plus I1 plus I2 plus into brackets minus I3 equals to is 0. I hope you can still see that. Okay, so equals to 0. So if I'm to continue it here, so we can also rewrite this as I1 plus I2 minus I3 is equals to 0. So if you to simplify this further, we are going to be having I1 plus I2 is equals to I3. Now what this is giving us is this. Is based on Kirchhoff current law. It says, which is what the algebraic sum of currents of electric current entering or leaving a node or a junction is equals to 0. We can also say that for Kirchhoff current law, the total current that is entering a node is also equal to the what? To the current that is leaving that node. That means I1 and I2, which is the incoming current, is also equal to the current that is leaving what? That particular node B. This node B, the current that is I1 is entering node B, I2 is entering node B, but I3 is leaving what? Node B. That means I1 plus I2, the combination of the incoming current is equal to the what? The total what? Outgoing current. So that's it on Kirchhoff current law, and it also follows the conservation of current. That is, the current that is entering is also the one that is going to be leaving. Now let me do a small illustration here. So let me rub this off. So you might pause the video, and if you want to write this down, so let me do an illustration here. So if you have any node, or any junction, let me take this, and we have, for example, in this example, we have 3 different currents, 2 are incoming and 1 is outgoing. So let's say we have a node, and then we have different currents. This is 1, 2, 3, 4, 5. So let's just pick at random. Let's say this is an incoming, this is an incoming, this is also incoming. So, and then we have the remaining 2 to be, let's take it to be outgoing, and then to be outgoing. So let's say this is I1, I2, I3, I4, and then I5. So what it basically means under Kirchhoff current law is that the addition of the incoming current, which is I1, plus, so each other one is the incoming current, I3, and then plus I4, is equals to, now these ones are incoming. Okay, you can still see it. So let me write it there that these ones are what? They are incoming. It's also equals to what? The outgoing current, that is, which is the sum of the outgoing current, that which is I2 plus I5. So that is what? Outgoing current. And if you don't want to represent it the way I've written it like this, you can also represent it like this other way. So let me rub this part off. So you can equally represent it like this, where all the incoming currents, remember all incoming currents are always positive, so you can go ahead and have some have it as I1 plus I3 plus I4, and while the outgoing current, they are negative, that will be plus the outgoing, that is, this I2 is outgoing, minus I2 then plus minus the other outgoing current I5 all equals to 0. This is what it's saying. It states that the algebraic sum of all electric current entering and leaving a node or a junction is equal to 0. And this is what I've just expressed here. So you can either express it like this or you express it this way. So if I'm to simplify this, I'm going to be having I1 plus I3 plus I4 minus I2 minus I5 is equals to 0. So if you should have this as I1 plus I3 plus I4 now equals to, now this one with negative, you should take it to the other side of the equals to sign. We are going to be having I2 plus I5, and you can see that what we are having here, what I'm having here is the same thing that I'm having here. So I hope with the explanation you've been able to understand what Kirchhoff current law is all about. Once you're able to understand that the sum of current entering a node or a junction is also equal to the current that is leaving that same node and junction. And now, so before we go, I also want you to, if you are confused of what a node is, what a junction is, please, there's a video I've done that explains the difference between all of these things: a node, a junction, branches, mesh, and every other thing. I'll leave a link to that video in the description. Also about Kirchhoff voltage law, I'm going to leave a link to that video also in the description of this particular video. So in the subsequent video, we are going to be looking at now mesh analysis, Norton theorem, and every other thing under current and circuit analysis. So thank you very much for watching, and if you are new here, please consider subscribing to this channel. It's absolutely free, and I'll see you all in the next video. Thank you.